So let's talk about that member variable with its lifetime tied to the class with that UML composition. One kind of old school approach would be that in the destructor, whenever we destruct any instances of the class, we delete that object out on the free store. As I mentioned at the very beginning, this causes you a ton of misery. Now all of a sudden you have to deal with copying. Do I want a deep copy? Do I want a shallow copy? Maybe implementing reference counting. The simplest thing to do, and C# and Java people who are coming to C++ often are really blown away by this one, so I want to explicitly state it, is just to make it a solid object in the class. Now this doesn't necessarily work if it's optional, but if every employee has a benefits plan, then just have a member variable that is a benefits plan, not a benefits plan pointer. You see this all the time when instead of having car stars for people's names, we just have strings from the standard namespace. Then when that person object is destructed, the string objects all go out of scope too, and there's no deleting or messing around on the free store necessary. Strings are just cleaned up. They're solid instances and they go away when the thing they're a member variable of goes away. Done. Is get you copy semantics for free. When the solid object person is copied from one place to another for whatever reason, all of its member variables, whether they're strings or whether they're benefits plans, will be copied. You write very little code. It's nice and expressive. Everybody kind of gets it. Sometimes people don't want to do this because they're concerned about the size of the resulting person or employee or whatever kind of object it is we're designing here. And sometimes they don't want to do this because, well, not everybody has one. It's optional. Or some people even have more than one. And so I'll use a pointer to, get access to an array of benefits plans, let's say. No. If you don't know how many there will be, use a collection. Let's say vector. How many benefits plans is one employee going to have? Not 1,000. So have a collection of benefits plans. And each of those are solid objects in the collections. It's not a collection of benefit plan pointers. You could even do this when it's optional, when it's 0 or 1, because the vector might not have any elements in it. I'm not crazy about that. I think I have a better approach. But if it could be, 2 to 7, go ahead and use a vector of solid objects. When the employee goes away, its collection, its vector will go away, and as part of that, each of the solid objects inside the collection will go away. You don't have to write the code to make this work. Now, I don't like using it for optional when it's 0 or 1, and sometimes people will say, look, the thing that you might have one of is enormous, it's too big. I need to put it on the free store. Okay. You can then have a smart pointer, a unique pointer to that object out on the free store. Unique pointers have lower overhead than shared pointers. They do, however, make your objects uncopyable. That's the point. A unique pointer means no one else can have a pointer to it. You can get around that by writing your copy constructor and your copy assignment operator. Or you could take a shortcut and use shared pointer as long as you are okay with those semantics. Now, don't take this as a negative on unique pointer. When you had a raw pointer, that was also still the truth. You couldn't just copy it. You had to figure out, do I want a shallow copy or a deep copy? You had to make sure that the destructor didn't get triggered on the temporary and call delete on the pointer and then invalidate the original object. Using unique pointer instead of raw pointer does not add work. Using shared pointer instead of raw pointer subtracts work, which is great. I like doing less work. Shared pointer isn't always appropriate if you really needed to do a deep copy. Again, I consider this to be a feature that if we use shared pointer, we're saying something about our ownership of that pointer. If we use unique pointer, we're saying something about our ownership and we're gaining expressivity. But look, let me give you some code to show you how to handle a member variable that you might have thought of using as a pointer and instead taking these approaches to managing the lifetime of that member variable.